Hi, I'm Oliver Cox, founder and CEO of HSM. This is the first video in a series on our values. And this first value that I want to talk to you about is both, I think, the most novel and different of the things that we care about, but it's also the most difficult to discuss and even to name. And to get us started, I think the best way to introduce this idea is to say that we care about software that's shaped like human thought. Or we think that the software that humans work with should be capable of conforming, of shaping itself like any human idea. And let me express that and let me visualize that for you first by distinguishing the way in which computers operate and the way in which we operate as humans and the way in which we think. I think it's pretty unambiguous that computers, on the whole, digital computers, operate in sequences. The processor executes one instruction, moves on to the next, or they should say the processor core moves on to the next, moves on to the next, in a sequence. One memory location on your disk, in your RAM, follows the next, etc. And as a result, the first things that we did with computers one of the first things was to string things together, like strings of characters, or arrays. These are some of the most basic things that we do with programming. And you could do a lot with this sort of stuff. But then you can interleave various sequences like this to create more useful structures. One of the most common is, of course, the tree, which is a structure where any element has one and only one parent. And you can see that this tree is, or can be made from, several individual sequences. Similarly, you can arrange a number of sequences together, interleaved like this, to make a table. And these things, these tables, these sequences, and these trees are very useful. And I would say that probably 95% of the things that the regular computer user does with their computers falls into one of these categories. Your text file in your text editor, that's typically just a sequence of characters. Your file system on your computer or your document structure on your web page are typically hierarchies or trees. And your database, your relational database or your spreadsheet is typically some form of table. But the problem with these structures is that I would say the most interesting things that we think about as humans and the most meaty, difficult problems that we have to solve as a society don't look like this. And let me give you an example of this from just a regular professional. So let's say we're dealing with a marketing manager. Let's say we're thinking about a marketing manager. Let's say they've got a set of documents, and here's one of their documents. This is, for example, a blog post. They've got a social media timeline of what they want to publish. And they've got another document, their scope of work with their client, let's say. Now let's say that these are richly interconnected. So the social media post might reference the blog post. And of course, the scope of work references all of this work product together. Now, our marketing manager, should be able to have some tool that allows them to store all of these relationships and visualize them on screen. And despite the fact that many companies offer fairly capable information management tools, document-oriented, workflow-oriented, Kanban. This is a word salad. There's still no way to pull up all of these assets and to see these visual connections between them. And indeed, many of these connections, like this, are impossible to make depending on how you organize things. If you put something in a hierarchy or in a tree, you can only make these sorts of connections like this, such that something only has one parent. You can't do this, say. And what that means is that most professionals are in this computer straitjacket of the mind that prevents them from actually expressing what's up here, and instead allows them only to express some summary of it. I highly encourage you to read, to watch anything about or by the philosopher Ted Nelson. He figured out how to do hypertext and how to express information and text on computer screens in the 60s and 70s. And his vision is much more human and dynamic than much of what's available today. Let me expand on this idea a little bit and make it a bit more precise and a bit more quantifiable. I'm going to use a big word, but I want you to know that I'm not the kind of person that uses big words to try and impress you. Rather, I'm using this word because it will help me to explain things and help me to be precise. And it's not really a big word. It means something very simple, in fact. ID means idea, or thinking, or thought. Morphism means shape. And iso means like. And so at first blush, this just means shaped like human thought, just like what I was talking about earlier. But the useful thing about this word is that isomorphism has a narrower mathematical definition. And what isomorphism means is two things are isomorphic if you can make a one-to-one correspondence between the things that make them up. So let's say I have a tree here in my garden, forgive my artwork here, and an abstract mathematical tree here. I can say they both have a trunk and they both have 3 branches, which means that there is a direct one-to-one correspondence between all of their elements. You can switch back and forth between them without losing information. And I should say, or more broadly, were I to do this and add some branches to my abstract tree in my mind, it's now no longer directly isomorphic to the tree in my garden because it has a different number of branches. There's no longer a one-to-one correspondence between the individual pieces, but it's now isomorphic in the sense that they are both trees. That for every branch it has, for every branch there is, I should say, each one has only one parent. And in that respect, they are still isomorphic. And to extend this, that which is ideisomorphic has a one-to-one correspondence with the idea in your mind. Or, on a more abstract level, it has a one-to-one correspondence with the structure of the thing in your mind. So let's go back to our marketing manager we were thinking about earlier. Let's say that they're working on a long and complicated multi-thousand word white paper. And let's say that it begins the rain in Spain. Now let's think about the way in which we conceptualize articles and text and writing in the mind. And let's focus on the application thereof for long and complicated writing, like white papers, like books. So we of course think about words, we think about sentences, paragraphs, and even sections / headings. This of course varies from software to software, but in the most general case, for the software used by the most people, the only thing that you get in a text editor or a word processor is some way of entering characters and cutting them and pasting them and moving them around and changing how they look. And for me, when I'm writing, when I'm creating, I care about the characters only in an ephemeral way when I'm typing and for the sake of spelling. The characters are at best a secondary concern to me. What I care about is things that actually matter to the ideas that I'm expressing in, say, my white paper, like the words. So we care about characters, fine. Are there characters in our word processor text editor here? Yes. Are there words? Maybe, but not really. There are representations of words here, but the words themselves aren't uniquely identified. They're not things, really, and you can't do much with them. So I can't say drag them around or do a trivial dictionary lookup or analysis on these things. When you start to try and do those things, they become incredibly tedious and difficult. So I'm going to say no, there are not words in our document. There are merely strings of characters separated by spaces. Nor are there sentences. I can't look up my sentences. I can't do non-erroneous sentence count. I can't drag and drop my sentences. Nor can I do so with paragraphs or sections. And I'm, again, talking here in the general case. And so imagine that you are this marketing manager that we're talking about. And we want to edit our long white paper. One of the most important aspects of editing is rearranging. And the process of rearranging in most text editors or word processors involves selecting a piece of text, cutting it, and scrolling somewhere else and pasting it up, all the way up there. Now imagine if we're dealing with thousands of characters, multiple pages even, at once. Wouldn't it be better to have some way of doing that where you could just focus on the sections and have a list of sections and just move those sections around? Now, you can't do that. Or to the extent that you can, it's incredibly tedious and frustrating to do so. So, when we think in terms of ideoisomorphism, i.e., to what extent is there a one-to-one correspondence between the structure in our mind and the structure in our computers, we can assign a score. How many of the things that we care about are present? And let's say, for example, here we care about 5 things, and only 1 is present. So this is 1 out of 5. 1 out of 5, and we are thus 20% ideoisomorphic. So, to recap, we have this contradiction here between the sorts of things that we do in our mind, which are associative, ritually connected, can be connected in any way we like, graphs, nesting, clusters, and which is in contradiction with this world here of sequences, of tables and hierarchies. And let me explain how I think that this is in fact rather dangerous, and that in some ways our society is in some form of peril because of this problem. In my view, and I think a lot of people agree with me, that we're in something of a feedback loop with respect to technology. Which is to say that the way we think influences the ideas we come up with. And the ideas that we come up with influence our technology. And this feedback loop goes round and round and round. And the risk is that, I should say, what this means is that because the ideas we have influence the tech we create, and the tech we create influences how we think, we risk getting stuck in this world that I described earlier of hierarchies and tables. Because everybody thinks like that, so they want to create more technology like that. Indeed, sometimes you meet people for whom those are the only things they typically think about. You, I'm sure, have met the spreadsheet head, the database head, the hierarchy head, the tree head, who thinks that things that don't fit into that mold are somehow problematic or irrational or aberrant. I know you know these people. And I'm not trying to make a moral judgment against these people. It's natural that people would be tricked into thinking like that, because how else could they? The tech says it should be that way. But the problem is that when we come with new ideas and want to break down the walls here, a lot of this stuff is confusing for people, and it's hard to explain these things and hard to make progress. The risk here is that we're going down this spiral and getting narrower and narrower in our thinking, to the extent where there may come a time where it becomes impossible to break out, where we lose the ability to think about complex, nuanced, networked problems. And as I mentioned before, the most challenging problems facing our society, complex social problems, environmental problems, are of this nature. They relate to things in networks with many relationships between them, with relationships between relationships, different categories, overlapping concerns. And so this spiral that we're going down in our thinking, I think, will make it harder and harder for us to challenge and to solve the problems that we face as a society. Imagine that you are an air traffic controller, and you have some number of planes in your airspace, and you're in charge of making it so that they stay in flight, avoid crashes, etc. I think it's pretty unambiguously true, or obvious, that in order to function in that role, you need to have some map, some representation of the planes in your airspace and their location that's stored somewhere. It could be on a table with models, it could be in your head, probably better to be in a database on your computer. And to the extent that you don't have that, you are essentially guaranteeing failure. Now, let's go back to our word processor example. We have all of these elements here, which are like the planes flying around in our airspace, but we only have representations of the characters. And what that means is that we are essentially guaranteeing that we will have failures and problems and that things will get out of control with respect to the things that we can't visualize or model in our system. And this is, I think, the cause of the problem that I think many businesses experience, which is that you create some form, you create some system, some document, and it reaches a point where it gets so complicated and so big that the tools stop being able to manage it. And if you look in any company's document system or project management system, you'll see this process happening again and again. The philosopher of systems, Stafford Beer, talks about waves coming into the beach. The wave comes in, and eventually the internal dynamics of the wave crest over and it collapses because the wave can't manage the changes around it. And this happens all the time in companies. Their systems, their documents, their ideas get too complicated to manage. But the reason why that happens isn't any inherent problem with the ideas or even the people. The problem is that our ideas look like this, but the only systems that we have to express these ideas look like this. They look like sequences, tables, and hierarchies. And that's why this matters so much to us at HSM. I'm not going to show it to you today, but we have created an application called Coius. And Coius allows you to do all of this stuff naturally. It allows you to express relationships between objects in any way you please, and to store those objects in a straightforward syntax that is open and interoperable, so anyone can work with this. And it, of course, allows you to visualize these things on screen in a clear and culturally universal way. And I will include a link to a video demo, in the show notes here. So I'd like to leave you with 3 requests. 1, please check out Coius and let me know what you think. This is a new application, so I need a lot of feedback, and this is not for me, this is for you. And I want to know what you think of it. 2, please, to the extent that you're able, read and watch anything that you can by Ted Nelson. He is a true humanist. And to the extent that Coius doesn't move the needle for you, please demand more from your software providers. I don't think that many software providers see the big picture here, and I think that it's holding us back. And I think we should all demand more from them. So with that said, I really appreciate you taking the time to be with me today. I look forward to hearing from you and to hearing your feedback. And I look forward to speaking with you and spending some more time with you soon. Take care.